everybody. It's good to be here. I'll spend a few minutes to tell you more about the project that we have embarked on together with the D-Shape and together with the World Wildlife Foundation. But before I jump into that, I'll just tell you a bit about who Ørsted is. Many of you may know, but some in the audience may not know. I'll tell you a bit about sort of the context for even diving into this project, why we're doing it, before we then get to the actual project, which Enrico can also tell you much more about. So about Ørsted, I'm not too familiar with who's in here, but just very briefly, we're a global leader in green energy projects. We are the market leader in offshore wind. We've been part of pioneering that industry over the past 10 years. We've built more offshore wind farms than any other company in the world, and we have more in the pipeline than any other company in the world. We're also building our presence in onshore renewables, both solar and wind, particularly in the US, but also increasingly in Europe. And then what most Danes are familiar with are the power stations that we still have in Denmark and will continue to have, but that's actually not the part of the business that we are scaling. That is really the green energy part of the business that we've been building over the past 8 years in particularly, and where we are really sort of making a difference worldwide because we are a part of pioneering that. That was for those who don't know Ørsted. And then, as I said before, the big impact that we're creating in Ørsted and that we are really set on this planet, I would say, today to make is to help transform from the use of fossil-based energy, so oil, coal, and gas, to renewable energy. And why is that so important? Well, that is because that 73% of global emissions worldwide, they are linked to the production or the use of energy. So as societies, we are addicted to fossil fuels, and it's a huge problem. So in order to limit global warming, to avoid the catastrophic consequences of global warming that we're already starting to see, we need to transform away from this addiction to fossil fuels. And that's why we in Ørsted, we've committed to run our company in a way that's in line with what science requires from companies to be a part of the solution. And through our low-carbon green solutions, we want to help others do the same. And why am I talking about all of this when I'm at a 3D printing conference? Well, I am because our vision is to create a world that runs entirely on green energy. And just as an example, offshore wind is a key component of such a green energy system. It's not the only component, it's one component. It's not the only part that we're building of such a green energy system, but it's an important part. And now to the part around nature and artificial reefs and so on. When you build green energy projects, they are large infrastructure projects. And when you do large infrastructure projects, it's unavoidable that you have impacts on nature where you build. So what we want to do is to make sure that the impacts that building green energy projects have on nature, that they're limited, that we actually build and lead a green energy transformation that goes hand in hand with nature, so that we don't build solutions to climate change and through that contribute negatively to another huge crisis, because we have a nature that is also under immense pressure. So that's where sort of the biodiversity comes in. And what is biodiversity? Well, in simple terms, biodiversity is variety in species and ecosystems on Earth. And why care? Well, actually because they are the fact that we have healthy nature, that we have healthy ecosystems, that is a key component to life as we know it. We're dependent on healthy ecosystems for human health, for food systems, for mitigating climate change for that matter. So to contribute to also continue to have healthy nature is super important. We cannot solve one crisis by adding to another, and we cannot solve the climate crisis if we don't also sort the environmental crisis. So in that way, they are really two crises that go hand in hand. And just to give you an image of how you've probably all a bit tired even of hearing about global warming and the crisis related to global warming. Well, in fact, 70% of species have disappeared since 1970. So this is another huge and quickly evolving crisis that we cannot ignore. So our biodiversity in Ørsted is that by 2030, at the latest, the energy projects we commission, whether they are offshore or on land, they have to leave nature better off than before we started the project. In sort of nature terms, we call that we want to deliver a net positive impact on biodiversity. And that's really that's an ambition we set out last year to make sure that we build green energy projects, as I said, that is part of the solution, not only to the climate crisis, but takes into the account the added impacts of building green energy projects. So we actually believe that we can develop energy projects, wind farms, that contribute to the solution. And here comes the project that we will talk about today, because one of the things that we've done, and it's only one, but it's a really important project, is that we've been piloting these 3D printed reefs, which Enrico will also tell you more about in a minute, at our Anholt offshore wind farm. Because the challenge with building net positive offshore wind farms is that we don't know how to do it yet. It will require that we change the project development, how we think about to construct and build offshore wind farms, and think about how we can make sure that nature, the wind farms themselves and other users of the oceans can exist together. And we want to make our wind farms nature positive in the way that they are areas that actually contribute to positively to nature conservation. So the specific project here is that together with the WWF, the World Wildlife Foundation in Denmark, and Ørsted, and also D-Shape, we have inserted these 3D printed artificial reefs into our Anholt offshore wind farm. They are about 1 cubic meter. They're built of natural materials, so if they erode, they will not have a negative impact on the natural environment. The challenge with Danish waters is that a lot of the ecosystems has disappeared. The natural ecosystems are built up from big boulders, big stones, but they've actually been removed to be used for coastal protection, building, construction, and so on. So under the water, we to a large extent have deserts. And it's an ambition of the Danish government to restore the ecosystems underwater. And these 3D printed reefs can actually be a part of that solution, because they create that place for fishes to live. Specifically here we have focused on the cod. The cod is a threatened species in Kattegat. It's a super important part of the ecosystems because they are a predator. And if they're not there to sort of regulate the ecosystem, other species, such as crustaceans, crabs, they will take over and sort of destroy the ecosystem. So having the cod there is super important to the full ecosystem. So we've piloted this project to see if this is a part of an offshore wind farm, what can it actually do to the environment in that area. We have also done a parallel project in Grenaa, which is close to, where we have inserted biohuts. They're like, it looks a bit like one of those trolleys you use when you go shopping, filled up with rocks. They are attached to the harbor side, and what they do is they give a safe space for the small fishes, so that they have a place where they're safe, where they can live before they swim to deeper waters, and that's then where we have these artificial reefs. The scale of this project will not save the ecosystem in Kattegat. the important part here is that if we are to sort of start building up our ecosystems underwater, we need to build new knowledge, we need to build new data, we need to collaborate to find the solutions that will contribute to restoring nature, and that's what this project is meant to do. I will not go into the details here, but just to say it's one out of several projects that we are piloting to learn what works in different ecosystems, because as we develop wind farms in more geographies across the world, we will also be working in and impacting ecosystems that are different. So therefore, we need to build up different experiences to learn what will actually work so that we eventually can build those net positive wind farms that are part of solving the nature crisis that we are seeing. I'll stop there to leave enough time for you as well.
Thank you, Ida. Ciao, Copenhagen. Good afternoon from an Italian engineer. I have a nice story to say that is behind the artificial reefs. If I find out my presentation, easier. The story of the 3D printer reefs starts from far in time. I'm from Pontedera, that is the city of Vespa, and the story behind belongs to the sphere of visionaries and inventors. I grew in an environment of innovation and disrupting challenges. So when I grew, I wanted to do something big, as my father and my good father, Corradino Tascanio, did. And in the 2004, I was really fascinated by an innovative manufacturing technique that was 3D printing. There is a 3D printer called Z-Corp that really was fascinating to me. And one day I came up with the idea to scale up the system and print houses. So to do so, I committed my life to file a patent, to build up a machine from scratch, develop a software, and develop a scaled-up machine using sand. The machine was just a tool to achieve a new architecture. So the idea was an idea of not developing robotics, but giving mankind, let's say, a new tool to rewrite architecture and to shape a better world. So the crazy idea was to follow the marks of Antoni Gaudí, because Gaudí was a precursor of topological optimization. And so the idea was to build something that might be impossible to do with the technologies of precast, for instance. So Andrea Morgante, an architect in London, developed for me an idea of a skeleton that might be 3D printed. And so running the printer, we built up the Radiolaria pavilion that was featured as the first 3D printer sculpture in the world, and they became very famous for that. So what was amazing is that the head of the building site of Sagrada Familia is from Australia. So suddenly, having the chat with Mark Berry and James Gardner from Melbourne, they said, why you don't use this technology to make something that is more environment friendly, more sustainable, more cool to save the planet? And said, wow, I love the sea, let's do that. So James Architect and David Lennon, two biological engineers, shaped a coral reef that we printed in 2011 in Pisa, and we deployed in the Sea of Bahrain. And the project was incredibly successful because fish really love fancy shape, has a sort of aesthetic sense. The process is a very simple process because it's just a layering process. Many of you probably have seen the particle bed 3D printer. In this case, this printer is 5 meters by 4 meters, is a machine that has 300 nozzles. an array of 300 nozzles is basically an inkjet printer. The ink is a structural ink that turns sand into a sandstone using oxide. So to unveil the object, you have to remove the unbound sand and unveil the reef. So is a process that is very dusty, but allow the realization of shapes that are almost impossible to build up without this kind of process. So the idea, having developed the 3D printer, the topic was to have the right software to shape such complex shapes. So thanks to some talentuous millennials, among those Mirko Daneluzzo, Alessio Rioli, and some guys of computational design Italy, they started to propose to me the algorithmic models to achieve the, let's say, the shapes that are good to attract fish. So I've been invited to explain why 3D printing, on how and why and when and if. The if is gone, but why 3D printing might be good is good for coastal restoration, for marine regeneration, and so forth. And the reason I might have several justifications to do so, but let's say that merely by a geometrical physical perspective, the reason of using 3D printed items is because the ratio between the surface and the volume can be extremely high, much higher than a precast. Compared to 1 cubic precast reef, if you want to call a cube a reef, we can achieve a ratio of, let's say, bioattractivity, that is the ratio between the surface and the volume and also the roughness, is up to 10 or 20 times, if you in some cases, higher than precast. And And so, along this, the lesson learned of this experience of making artificial reefs was spiked by a video that I saw while the artificial reef was deployed into the seawater. Meanwhile, the reef was deployed, the fish started to come and settle and colonize the reef even before touching the seabed. That was absolutely amazing. So I started to realize that fish have an aesthetic sense. Maybe I'm wrong, but they really love pattern, whatever they are. And I came up with my personal own idea of beauty that is related to math, basically, because our brain is fascinated by math and harmony of algorithmic approach. So, as well, a fish perceives as beautiful, a fantastic and fancy pattern. As well, I guess that the ordered process of demolition, that is shaping, is a source of creating a fancy shape that we can define beautiful or at least fascinating. So, no limit to the imagination about what we can do out of 3D printing for the marine restoration or for diving or both, or merging into the same pot technology, entertainment, diving, entertainment, tourism, and so forth. So this is just the beginning. The project that we have done here in the Cattedra come out after a series of pilot projects in Monte Carlo, in the Netherlands, in Spain, and the last project has been made is undergoing in Hong Kong, where hopefully we shall have the chance to create a 60 hectares or even more artificial reef into the Bay of Hong Kong. And we have to think big, but print big, but even thinking bigger. Because the opportunity given by 3D printing for applied to marine restoration is really releasing the refrains of the imagination and creating opportunities to restore the environment with huge realization. Thank you, and this is all. Thank you.